Hello friends and welcome at my channel. Happy New Year to all of you guys. Thanks for watching. I would like to do one more video, the first video of this year on YouTube for where I'm computing domains. So 3 more cases that we're going to discuss and then we move on to next topic. All right, so one of those questions is like maybe one more square root f of x equals to square root out of 2 plus x minus x squared. So how can we compute this one? Well, basically it's about understanding of this parabola. In order to understand it, we just compute the 0 points, all right? So we put it equal to 0. Then, I don't know, if you're American or actually almost everywhere, not in Germany, from Germany, you are using ABC formula in Germany, especially in the part where was living, Düsseldorf. It's North Rhine-Westphalia. There is so-called PQ formula, so it doesn't matter actually which one you choose, but somehow you have to compute the 0 points. Let me show it to you. Maybe if you're an English speaker who is watching this video, just let me show you some German mathematical traditions. It's x squared minus x minus 2 equal to 0, and now it's a kind of shortcut of the ABC formula. X12 is equal to minus p divided by 2, so p is the value x squared plus px plus q, so p is the coefficient in front of x, in this case minus 1, so a half plus minus square root out of a half squared plus 2, which means we have 0.5 plus minus 2.25 square root is 1.5. So that means x1 is minus 1 and x2 is 2. So minus 1 and 2, and it looks like that. All right. So where are we supposed to have x values? Obviously between minus 1 and 2. Otherwise we have negative values. So x is minus 1 included, 2 is included as well. That's it. And the PQ formula, just to write it down, is minus p half plus minus square root out of p half squared minus q. Maybe you've seen it somewhere, I don't know. But if, once again, ABC formula, it's a special case of the ABC formula if a is equal to 1. All right, let's move on. Let's maybe do one more example. F of x equals to square root out of minus x plus 1 divided over square root out of 2 plus x. So I'm just doing some exercises from internet or whatever. I just was thinking about starting at the very bottom and going up as far as I will make it. I don't know. That's why I think domain is a good topic to start with the basis. Okay, so what do we have here? First of all, we have 2 square roots, and then we have a fraction with the denominator. So first of all, x shouldn't be equal to minus 2. And then minus x should be bigger or equal to 0. That means if minus x is bigger or equal to 0, that means if you multiply times minus 1, right? Okay, you can see it immediately, but if you multiply, if you do it like algebraically, multiplication times minus 1, you have to change the direction of the inequality, which means you got this one. And that would mean that, oh, my bad, sorry. Less or equal than 0, yeah. That would be nice, to multiply 0 times minus 1 to get a 1. No, x is just negative, or 0. So x is negative or 0, but you see x shouldn't be minus 2, right? So anyway, we just have to keep minus 2 out of the business. And what about the denominator? Well, 2 plus x should be also bigger or equal to 0. So that means x is bigger or equal to minus 2. So on the one hand, we want to be less or equal than 0. On the other hand, we want to be bigger or equal than minus 2, but minus 2 must be excluded. So you see, x is starting from minus 2, where minus 2 isn't included, it's excluded, and 0 is fine, it can be included. All right, so that's the second example. And the third example that I want to present is f of x equal to square root out of the sine of 2x. No logarithms tonight. All right, what about this function? Well, once again, square root. Well, sine has no problems at all. But with sine of 2x, well, we just have to see what's going on. First of all, you see the period is changed, so this sign is kind of fluctuating faster. So that means we start at 0, and normally the normal sign would be that would be pi, and that would be 2 pi. Let's picture one more graph. That would be looking like this. That's the normal sine curve, right? But with the sine of 2x, things are moving faster. That means we're doing the whole wave twice. So that means we are having pi divided by 2 here and 3 pi divided by 2 there. And we still start in 0, but as you can see, we are not so nice. Doing my best. Am I right? Yeah, kind of. Okay, and once again the same here. So like this. All right. So the graph that we are interested in is the green one. The height should be actually the same everywhere. Sorry for this. And now we are interested in the parts of the sine curve, sine of 2x, which is above the x-axis. So that means we're interested in this part. And we are also interested in that part. So as you can see, x is from 0 to pi divided by 2, and from pi to 3 pi divided by 2, and so on. But then you can say, well, that means actually we are taking this interval from 0 to pi divided by 2, and then if we add pi to this interval, so if we add pi to 0, we're going to get at pi. If you take pi divided by 2 and if you add pi, you're going to get here 3 pi divided by 2. So that means basically what we can write, we have all the integers, multiples of pi to this interval. Let me write it this way. So that means you are kind of having only small parts of the real axis which is allowed. We are taking, and k is just an integer. We can go to the left-hand side, but we can also go to the right-hand side. Okay, enough for today. All the best in the new year for all of you, not only for the students interested in domain computations. I hope you'll enjoy and learn from my lectures. I would like to be as productive as I was in the last few weeks. All the best, guys. See you in the next video. Bye-bye.